Hello everyone and welcome to 30 days of DSA challenge where we will be solving a DSA problem every day for the next 30 days. So this is our day number 26 and today we are again going to solve a problem based on greedy algorithms and the level of this question is going to be medium. The name of this question is Jump Game. You will get this question link in description and you can also download this Excel sheet from description. Now without wasting much time, let's see our question on Leetcode. So now we are here on Leetcode. So let's read our question. So the question says you are given an integer array nums. You are initially positioned at the first index and each element in that array represents your maximum jump length at that position. Return true if you can reach the last index or false otherwise. So question is saying that I have given you one nums array, right? And this nums array is having integer values. Initially, you are standing here at index number 0, right? Which is the first index of our array. And you want to reach to the last index of your array, right? You want to reach your last index of your array. And every element represents the maximum jump you can take from that particular index. Okay? We have to return true if it is possible to reach to the last index. Else, we have to return false. So firstly, let's analyze these two sample test cases and then we will think of how we can solve this problem. So let's take this particular nums array and let's say that initially I am standing here at index number 0, correct? So when I'm standing here at index number 0, the element which is present at this index is 2. What does it mean? It means that either I can take a jump of one index or I can take a jump of two indexes, right? Because the element which is present at the index number 0 is equal to 2. So it represents that at max, I can take a jump of two elements. Okay. So let's say that if I'm taking a jump of one element or of one index, I will reach here at index number 1. Okay. I will reach here at index number 1. So the element which is present at this index is 3. What does it mean? It means that from this particular index, you can take a jump of 3 indexes. Okay, so if I take a jump of one index, I will reach here, which is index 2. If I take a jump of 2 index, then I will reach here at index number 3. And if I take a jump of 3 indexes, then I will reach here at index number 4. And this is indeed the last index. Okay, so from this particular test case, it is very clear that yes, it is possible to reach to the last index. If it is possible to reach to the last index, then we have to return true. So for this particular sample test case, we will return true. Okay. Now let's take this second test case. Okay. So initially we will be standing here at index number 0. Okay. So the element which is present at this index is 3. What does it mean? It means that at max, I can take a jump of 3 indexes and I can reach at index number 3. Okay. And the element present at index number 3 is 0. What does it mean? It means that if you are standing here at this index, then at max, you can take a jump of 0 indexes, right? It means that if I'm standing here at this particular index, then it is not possible for me to move to the next index. Okay. So if I'm following this path, then it is not possible to reach to the array end. So initially, when I was standing here at index 0, the element which is present at this index was 3. Okay. It means that at max, I can take a jump of 3 indexes. And when I took a jump of 3 index, I reached at index number 3 and the element at this index was 0. So now it was not possible for me to reach to the next index. So what I'll do, I will try to take a jump of 2 indexes. Okay. So if I take a jump of 2 indexes, then I will reach here at index number 2. And the element which is present at this index is 1. What does it mean? It means that at max, I can take a jump of 1 index. So from index number 2, if I take a jump of 1 index, I will again reach to index number 3 and the element present at this index is 0. It means that from index number 3, it is not possible for me to move further, right? It is not possible for me to move to the next indexes, right? So when I was standing here at index number 0, I could have also taken jump of 1 index. So if I take a jump of 1 index, then I will reach here at index number 1. Okay. And the element which is present at index number 1 is 2. What does it mean? It means that at max from this index, at max from index number 1, I can take a jump of 2 indexes, right? So directly if I take a jump of 2 indexes, then I will again reach here at index number 3. Here I have 0. It means that I cannot move further. I cannot move forward. Okay. So from index number 1, I can also take a jump of just one element, of just one index. Okay. So if I take a jump of one index, then I will reach here at index number 2. The element which is present at this index is again 1. It means that again I can only take a jump of one index. So if I take a jump of one index, then I will reach here at index number 3. An element present at this index is 0. It means that I cannot move further, right? I cannot move to the next indexes. Therefore, we have tried all the jumps which was possible, but at the end, it was not possible for us to reach to the last index. Okay. So for this particular sample test case, we will return false, saying that it is not possible to reach to the last index. So this was our question. I hope the question is clear to you. Now we will think of how we can solve this problem. So let's take this particular test case to understand how we are going to solve this problem. So let's say that initially I am standing here at index number 0 and my target is this, right? My target is the last index, which is index number 4. Okay. So when I am standing here at index 0, I will try to find out what is the maximum jump I can take from this index. Okay. See, because if I will take the maximum jump, then I will get more closer towards my target. Okay. I want to reach to my target. So I will see what is the maximum jump I can make so that I'll get more closer towards my target. Okay. So when I was standing here at index number 0, the element is 2. What does it mean? It means that either I can make a jump of one index or I can make a jump of 2 index. Okay. So let's say that if I decide that I will make a jump of one index, then I will reach here at index number 1. Okay. And now the distance between me and my target is of 3 indexes. Okay. 2, 3 and 4. Similarly, let's say when I was standing here at index number 2, if I decide that I will make a jump of 2 indexes, right? Then I will reach here. Then I will reach here at index number 2. Okay. And now the distance between me and my target. Let's see the distance. So now the distance between me and my target is of just 2 indexes. Okay. So when I took a jump of 2 elements, right? When I took a jump of 2 indexes, then I reached more closer towards my target. And in order to solve this problem, I need to reach to my target. Okay. So whichever maximum jumps takes me closer to my target, I will consider that particular jump. Okay. So this is the intuition or the thought process which we will use to solve this problem. So in order to solve this problem, we will use some couples of variables. Okay. So let's say that I have one variable named as I, and it will be initialized with a value 0, right? And my I will be pointing here at index 0. Apart from this, we will also have one variable named as maximum jump, and it will be also initialized with a value 0. So this maximum jump variable will determine the maximum index where I can reach by taking the maximum jump from my current index, right? And this I is my current index. So initially when I was standing here at index number 0, so the maximum jump which I can take is of 2 indexes. Okay. So currently I am standing at index number 0 and the maximum jump which I can take is of 2 indexes. So at max I can reach to my index number 2. Okay. This 0 is nothing but the value of I, and this 2 is nothing but the nums of I. Okay. So now we will compare these two with the value which is present inside my maximum jump. So inside my maximum jump, I am having 0. And the current value which I have calculated is 2. So this 2 is greater than 0. Okay. So now what we will do, inside our maximum jump, we will directly write 2. Right. So this maximum jump variable signifies that if I'm standing here at index number 0, and if I take the maximum jump, then at max I can reach to my index number 2. Okay. So now it is very clear that I can definitely reach to this index number 2. Okay. I can definitely reach to this index number 2. So now my I will get incremented, and now my I will point here at index number 1. So when I'm standing here at index number 1, at max, I can take a jump of 3 indexes. So my current index I is pointing at index number 1, and the maximum jump which I can take is defined by nums of I. So nums of I is my 3. Okay, so I'm standing here at index number 1, and from this index number 1 I can take a maximum jump of 3 indexes. So now I will reach to my last index, which is index number 4, right? I will again compare, is this 4 is greater than 2? So the answer is yes. So now what I'll do, I will directly update my max jump, and inside my max jump I will write 4, right? This 2 was nothing but the previous value of our max jump. Okay, so this max jump is equal to 4. What does it signify? It signifies that if I'm standing here at index number 1, and if I take the maximum jump which is allowed to me to take, then I will definitely reach here, which is my last index. Okay, and at any time, if my maximum jump is greater than or equal to n minus 1, I can just directly return true. Why? Because this n minus 1 is the target index where I want to reach. Okay, if my max jump is equal to 4, it means that I can surely reach to my last index. Okay, from this index number 0, I can take a jump, and then I will reach here at index number 1. From this index number 1, I can take a jump of 3 indexes, and then I will directly reach to my index number 4, which is my target. Okay, so now let's take this particular sample test case where it is not possible to reach to our last index. Okay, and here we will see that how our algorithm will work, which we have just thought of. Okay, so initially I will be standing here at index 0, my eye will be pointing at index 0, and inside my maximum jump I will have 0. Okay, so again when I'm standing here at index number 0, I will see what is the maximum jump which I can take from this index, right? So the element which is present at this index is 3. It means that at max I can take a jump of 3 indexes. Okay, so my eye is currently pointing at index number 0, and the maximum jump which I can take is nothing but nums of I, and this nums of I is equal to 3. Okay, so if I add these two values, I will reach here at index number 3. Okay, so from index number 0, if I am taking a jump of 3 indexes, then I will reach here at index number 3. But before going to my index number 3, I will compare these two values, this 3 and this maximum jump. So this 3 is greater than 0. Okay, so now what I'll do, inside my maximum jump, I will directly write 3. Now this maximum jump signifies that when I was standing here at index number 0, I can take a maximum jump of 3 indexes, and I am very sure that I will reach to index number 3. Okay, just hear it very carefully, that if my maximum jump is equal to 3, it means that for us it is definitely possible to reach to this particular index. Okay, it is possible for us to reach this particular index. So now we will increment our eye. So now my eye will point to the next index, which is index number 1. When I'm standing here at index number 1, the element is 2. Okay, so if I just add the values of I and my nums of I, so I is pointing at 1 and the nums of I is 2. So if I add both of them, I will get 3. Okay, and you can clearly see that this 3 is not greater than the maximum jump, right? My maximum jump is equal to 3, and this is the 3 which we have calculated. So it is not greater than 3. What does it mean? It means that if I'm standing here at index number 1, and if I take the maximum jump which is allowed to me, then I will still reach to index number 3. Okay, so we do not need to update this max jump. We will only update it when we are getting a better, when we are getting a better maximum jump. Okay, so I hope this is also clear to you. And now we will move to the next index. So now my eye will point here at index number 2, and the element which is present at this index is 1. What does it mean? From this index, at max I can only take a jump of 1 index. Okay, so if I add the value of I and nums of I, so the value of I is 2 and the value of nums of I is 1. So if I add them, I will get 3. What does it mean? It means that from index number 2, if I take a maximum jump which is allowed to me, I will reach to index number 3, right? I will reach to index number 3. Okay, and as this 3 is not greater than my maximum jump, I will not update my maximum jump. Okay, so now we will move to the next index, which is index number 3. Okay, so now my eye is pointing here at index number 3. Okay, so the maximum jump which I can take from this index is 0. It means that from this particular index I cannot move forward, right? I cannot move to the next index, right? So again, my I will get incremented, and now my I will point here at index number 4. So this is very important, okay? Just understand this, that I am standing at a index 4, okay? And inside my maximum jump, I have 3. This maximum jump signifies that the maximum index where I can reach by taking the maximum jumps is 3. Okay, so this 3 is the maximum index where I can reach, right? I cannot move beyond this 3. And when my value of I is greater than my maximum jump, what does it mean? What does it mean? It means that it is not possible for me to reach this particular index I, right? It is not possible for me to reach to this particular index I. In that particular condition, what I'll do, I will directly return false, saying that for me, it is not possible to reach that index. Okay, so this is the algorithm we are going to use in order to solve this problem. Just always remember that this max jump is signifying the maximum index where I can reach by taking maximum jumps, which is allowed to me. Okay, so in this particular case, the maximum index where I can reach is 3. I cannot go beyond this 3. So now let's think of how we can code the approach which we have just discussed. And trust me, code for this particular question is going to be super easy, right? So we know that the maximum jump initially, it will be equal to 0. Okay, it will be equal to 0. And I am running a for loop to iterate inside my nums array, right? So here initially my I will be equal to 0, and it will go until it is lesser than n. Okay, it will go until it is lesser than n, right? And at every index, I am just computing the maximum jump which I can take, right? So the jump which I can take at a index I is nothing but I plus nums of I. Okay, so if this particular value is greater than my maximum jump, then only I need to update my maximum jump. Okay, so here I can directly write that maximum jump is equal to maximum of this jump and maximum jump variable, right? So if at any point the jump which I have calculated is greater than my maximum jump, then the value of this maximum jump variable will get automatically updated. Okay, so this is something which we have to do inside my for loop. And here I can check that if my maximum jump, if it is greater than or even equal to my n minus 1, this n minus 1 is my last index, right? If this is the scenario, then I can directly return true. Okay, and after coming out from this for loop, we can probably return true. You can also ignore this return true statement, because if at any point my max jump is greater than n minus 1, then from this particular line of code, this true will automatically get returned. Okay, but when we will code it, you will see that we are coding this particular problem inside a bool function. Okay, so it is important for us to return something. Therefore, at the end, we are returning true. Okay, I hope it is clear to you. And now if we talk about the time complexity, then here I am just running one normal loop from I is equal to 0 up to n, and this n is nothing but the size of my nums array. So the overall time complexity is nothing but O of n, and the overall space complexity is O of 1. Okay, so this was the code and the time and space complexities. I hope it is clear to you. Now let's directly code it up on Leetcode. So now we are here on Leetcode. So very firstly, let me get the size of my nums vector. Okay, so here inside this variable n, I will get the size, and I also need one variable named as max jump, and it will be equal to 0. Then I just need to do one normal iteration inside my nums array, and I can do that with the help of one for loop. And here I need to write if at any point my I is greater than my maximum jump, then I have to return false. After this, I have to update my max jump variable. Okay, so my max jump variable will be maximum of I plus nums of I. So this I plus nums of I is the maximum jump which I can take from that particular index. Okay, and the value which is present inside my maximum jump. Okay, so if this jump value is greater than my maximum jump, then only I will update my maximum jump. Okay, and here I can also check that if my maximum jump is greater than or equal to n minus 1, then I can just directly return true. Okay, and at the end we have to return something because it is a boolean function. If I'll not return anything, I will get one error. Let me just show you. So let me just run this. So here we are getting one compilation error, and this compilation error is saying that non-void function does not return a value in all the control paths. Okay, therefore, as it is a non-void function, we have to return something, right? We have to return something. Therefore, at the end, I will return true. Okay, and after doing this, if I run this, then it should run fine. Here you can clearly see that both the sample test cases are running fine, but instead of returning true, what will happen if I directly return false, right? Now let's see this. So even at the end I returned false, and still all the two sample test cases are running fine. So now let's submit this. So here you can clearly see that this is accepted, and it is accepted even after returning false at the end. What does it mean? It means that at the end you can return anything, right? If it is not possible to reach to the end, then from this particular line of code, false will automatically get returned. And if it is possible to reach to the end, then from this particular line of code, true will automatically get returned. Okay, so it doesn't matter what you write here. You can either write true or false. So I hope this video was helpful to you. If it was, then make sure that you like to this video. Don't forget to drop a comment. And if you want this type of content regularly, then make sure that you subscribe to this channel as well. We will meet again tomorrow with a new question.